Hello and assalamu alaikum. My name is Fakisha, and in this video we will be talking about how to make C programming, how to do C programming of AVR microcontroller. So here I have my first program, which is we have to write an AVR C program to send values from 0 to 255 in decimal, that is FF in hexadecimal, to port B. So here you can see we are first including this standard AVR header file, and then we have this main function void in main, and then we unsigned char z. So both are 8 bits. Unsigned char b has 0 to 255 data range, and the char that is 8-bit has -128 to +127 data range. So here then we have a fall, then we are doing ddrb 0 cross ff, that is ddrb we are declaring as output. If I run it, you can see is all bits are on in this IO port. So this is actually declared as output. So back to this, then we are using a for loop. This for loop is increasing value in binary, that is 8-bit binary, and it will increase to 255. So then we have our port B. You can see we have port B as an output, and the Z is going and displaying on this. So this loop will run, as you can see first loop worked, and this 0 cross 0 1 on our display of port D. And then you can see as pin B is showing 2, pin B that is being uploading on port and then pin. In this way this loop is working, and it will move towards a 255, that is FF, from 0 to FF, and then the loop will start again from 0 to FF, and this will continue to move like this. So if I move on to my next program, so our next program is this one. Just let me copy paste it. Let's first stop debugging this one, the previous one. So let me first read the statement of this program. So in this program, we have to write an AVRC program to send hex values of for ASCII characters of 0, 1, 2, 3, 4, 5, A, B, C, and D to port B. So it is similar one, just a little bit difference. To build my solution. So should debug it. Okay. I debugged it. Okay. Let me open my IO ports. Yeah, the output. So we are using port B. Okay, fine. So in this program, we are just again including the standard AVR AVR header file, and then we are moving towards in main, and then we have unsigned char of 8-bit characters, and we have a list of list of arrays, that is we have this 0, 1, 2, 3 to D actually, and these are, we have to display their ASCII characters, what are their ASCII values of hexadecimal. So we have this then unsigned char z variable, and then we are using this ddrb as output port, and then we have the for loop that is running from 0 and is moving to the 9 in the incremental form. So it will run 10 times actually, because these are 10 characters. Then we are outputting it the port B, that is my list. So we are calling one by one each entry, and then we are displaying on port B, and what is being displayed is the hex characters of this 0, 1, 2, 3, that is in ASCII, so ASCII values. So if I run this loop, you can see it on this IO port connections of port B. So Here we have the port B. In the previous step, we had sorry, just stop running. Let me debug it again. So, okay, we're back. So here we have declared the DDRB as output port, and then we are giving the value of port B to be, that is 0, that is 30. Okay, then we have next character, that is ASCII value is 30, 31. As displaying 31. Next ASCII value is 32, and that next is 32. Next is 33. In this way, it's first getting it on port B and then displaying on the pins. So in this similar way, this code is we're working for 10 values, and then our loop will start again. So okay, this was explaining of this code. Now if I move on to my next program, so let me copy it again. Build solution. So what does this program do? Okay, the statement of this program is as follows: write an AVRC program to toggle all the bits of port B 200 times. So we have to toggle our ports 200 times. So what we will do, let me show by debugging it. Okay, okay, first we have this standard library, then the code starts from main, and then we have DDRB as the output port. Then we are on port B, we are doing 10101010, that is A. This is actually, if I write it, 10101010 in hexadecimal. So these bits are declared, the one are declared as on the port that we are giving a signal on, and these are off. Okay, so we have to toggle this thing. It will, if we will toggle it, it will become, from this side it will become 10 10 10 and 10. Okay, so then we are declaring this unsigned char character, and then we are running for loop, and we are doing over here, we are toggling port B over here. You can see this sign symbol over here. This is a toggle symbol. So if I show you from the IO ports, okay, continue. So you can say double A is 101010, and how it will be displaying it on pin B will be a toggle. First is displaying as it is, then it will be toggling it. You can see as this is on, this respective, it is not on, the next one is on. So in this way, as a loop is going on 200 times, the bits are being toggled again and again between AA and 55. So this was it from this code. Now we will move on to our next program, this one. So our next program is write an AVRC program to send values of -4 to +4 to port B. So we have to send -4 to +4 values that are, we have made, what do you say, list of characters and and then we are using -4, -3, -2, -1, 0, 2, 1, 2, 3, 4. So +4, and we are declaring unsigned char Z. Then we are doing using a for loop. Then we are, oh sorry, we are declaring this DDRB port as an output port, and we are using a for loop. And in for loop we are getting output of on port B of num z, that is this loop is looping for 9 times. So okay, um if I show you its outputs, so this is the value, this will activate my DDRB as output port, and now we are in the loop. So first value is -4, so -4, these all bits are being 1, they are red, and it displays on pin B. Then for next one, that is -3, and then this -2, -1, the 0 displayed, 1, 2, 2 is 2, that is 3, that is 4 being displayed, and that's it. This is the last one being displayed. So that was it from this code that we have to display from -4 to -4 to +4 on port B. So this is our next program. So this is our next program. Let me paste it over here. Build it first. Okay, now I will read the statement. So write an AVRC program to toggle all the bits of port B 50,000 times. So it is a similar code that we have done for toggling the port B for 200 times. We are using it now for 5,000 times. So similarly, it is we are declaring a port 5, and now what we are doing is we are declaring port B as 55 and then AA. So now in the previous example, we just used a symbol that was this one to toggle it. Now we are not using, but we are doing a symbol. We are just updating the value in the port B. So if I go and show you the IO ports, I think I have not debugged it. So now that our debug is being done, debugging is done, I should show you IO ports. So these are my IO ports. So this is declared as port DDRB is declared as output port. You can see now, you can see this is port B has these bits on, and that is bit 0, bit 2, bit 4, and bit 6 are being on, and this will be shown on pin B in the next move. And now when we are showing these bits on the pin B, our port B has toggled and the next value is being updated on it. And similarly in the next move, those will be being shown. And similarly in this way, the toggling will be continued for 50,000 times. So as it's being shown over here, for the loop is working. So this was a simple code program. If I move on to our next program, okay, so our next program is, first we will debug it, build the solution, stop debugging. Okay, so next program is write an AVRC program to toggle all the bits of port B 100,000 times. So this is a similar program, just toggling the bits, in the similar manner that we have done last time. Okay, so DDRB is the output port. We have made it output port, and now port B has 55, and this is uploading on pin B, and port B has now 0 cross AA, and now it's being toggling as the code is running. It will toggle the LEDs or anything you connect as output, and it will work for 100,000 times. So this was the toggling program. So if we move on to our next program, that is this one. So what does this program say is this program has a statement that is write an AVRC program to toggle all the bits of port B continuously with a 100 millisecond delay. Assume that the delay is at mega 32 with XTAL, that is crystal, of 8 megahertz. So we are using 8 megahertz crystal in this case. Okay, we're using 8 megahertz crystal in this case, and we are using port B as output port. So if I debug my program, okay. So first we are including the standard AVR header files, and then we are using a delay. That is a function of void void delay 100 millisecond void. Sorry, there's an error. I think there's a matter of this error is so I shouldn't come over here. What's coming? Anyways, I just explained you this code that is, I think its program is missing. Okay, let me write it. Unsigned int, sorry, int I, and we're using a for loop for I equals 0, semicolon I is less than 42150, semicolon I plus plus. I think now it should work properly. In broken, what's broken now? So our code is built successfully. Now if I debug it, so our program has debugged successfully, and now I move on to my IO codes. So this is a function that I have made for void delay 100 millisecond, and we are just running our program for 100 millisecond, that is 0.1 second, and we are just giving no values, and we are have assigned no values, and just running for 42150 just to create a delay of 100 millisecond, and we have made a simple function of it, and we are then moving on towards the main function that has DDRB as output port, and we have a while loop that will keep on running, and we can use random values over here and check out our response that it is 100 millisecond or not, and we can create any delay over here. So so port B is output port, and then we have a while loop, and this while loop will just toggle the bits, A and A and 55. But the new thing over here is this delay function. So if I run a program, you can see the port port B is the output port, and you can see a delay will come over here. You can see a blink delay has been occurring in this output port to toggle. So in this way, this code is working. So if we move on towards our next program, so this was the function that was this last time. Okay. Okay. So this is also a program. Okay. Build. Okay, so our eighth program is write an AVRC program to toggle all the pins of port C continuously with a 10 millisecond delay. Use a predefined delay function in WinAVR. So this time we are using a predefined delay function. Last time we made a function, but this time we are just including the function that has already been made for us in AVR Studio. So know what's build is failed. Anything missing? Let me see. It should not be doing like this. Some kind of function is missing. Okay. I think we have to include a delay MS. So we will be including void delay MS. So we will be using delay. You are here. So I think now it should work properly. So some mistake. Oh, I forgot this semicolon. So still a mistake with an area or cycles with a compile time integer constant. So we are including everything that is necessary. An error should not come in normal cases. So let's read it how it is working. We have to make a C program to toggle all the pins of port C continuously with a 10 millisecond delay. Use predefined delay function in WinAVR. Okay, they're using a port C, so we're using a port C. Sorry. So we're here. This is a define of crystal, 16 megahertz crystal we are using, and then we are including a delay function, a library, and this is AVR main library and the AVR header file, shared header file. Then we have this function void delay ms in D, which is a delay in D microseconds, and then we have DDRB is equal to 0ff, that is 0 cos ff, and then we are calling a delay function for 10 milliseconds. This will be declaring a 10. So actually there was no need of this function, but we can use it anyways, like this command. If I can use it like that, it should not give me an error. that it has built successfully. So now I debug my code. So here you have the input outputs in front of you. My port C would be on. What? Where is gone? So there should be a mark. Because there is a delay function, it has took me to delay. So library delay header file. So you can see here it has taken me. So in this way, this port will work with a 10 microsecond delay. Port C will display me 1 1, and then it will make it 0.55. So in that way, of one time these all bits will be on, the time these all bits will be off. Port use. So if I stop debugging and debug it again. So this time we're using port C. C everywhere, yes. You can see, and bit is empty. I don't know why. It should be empty. Let's see. So you got the point. It is working by delay of 10 microseconds. So we have used this time a library. So the next program we are heading toward is this one. You can see, so statement of this program is LEDs are connected to pins of port B. Write an AVRC program that shows the count from 0 to FFH, that is 0 in hex to all 1 in binary on the LEDs. So we are using here 16 megahertz crystal, and then we are using a higher file delay. We are including delay library, and we are using a standard library for AVR-IO. And then we have in main, we have all the bits as output for our B port, and we are using port B, that is output port B +1, and delay of 500 millisecond. Build this project, stop this, and let's debug it. So where was my IO ports? This is our IO ports. So we're using B. So all port B are our ports. So port C was not all because it has only 7 ports. Not all 8 ports are active in AVR Micro Studio. So AVR Mega 32P, 8P. Okay, so here it is using this one because of this delay. It is taken with the delay library. This kind of issues kind of come in simulation for this Atmos Studio. So you got the point. That is, we are adding one term by term to this port B. So if I move on to my next program, and my next program is, read its statement. The statement of program 10 is write an AVRC program to get byte of data from port B and then send it to port C. So actually it will be taking input from port B and then outputting it from port C. So it's kind of interesting. So debug it. Okay, so over here we have DRB as input port and C as output port, and you can see if I run this code, you see it's all as 0, and I move to port C, and now move my simulation, you can see is all 7 ports are active as output port. So then we have temporary, we are toggling it, we are moving on port pin B and saving in temp, and this temp is then outputting from port C. So we have got input from port B and gonna display it on port C. So playing port C. So it will remain in this loop. So cannot come out of this loop because while is 1, and while 1 is while is 1, we cannot move out of the port. So moving on to our next program, paste over here, build solution. So next program is, let me read this statement. Write an AVRC program to get a byte of data from port C. If it is less than 100, send it to port B, otherwise send it to port D. So in this, we are taking a situation. We are using an if statement over here. So you can see int main, we have used void unsigned char temp. We are using ddrc as 0, ddrb as output, ddrd as output, or c and d and b are both all our output. Our output ports. So if I my build has completed, if I debug it and move on, so our c is 0, our b is 1, D is 1, and now we are moving on the temp. So it's taken. So if it is less than 100, send it to port B. Otherwise, send it to port D. So if it will less than 100, go into port D. B. If else greater than 100, it will go into port D. So it is moving this way, all the bits of ATmega32HP. So if I move on to our next program, that is 712. So build a solution. The 12 program says run the following program on your simulator and examine the results. So in this code, we are just to examine our results, and you will see I'm using port B, port C, and port D, DDRB, DDRB, DDRC, DDRD as output ports. So first starting with the B is an output, C is an output, D is an output, and then we have to get output of port B as 35 and 0 0 F. This is the output on pin B, and now we are moving and we are doing a negation, and it's toggling it, port B, and our loop ends over here. So in this way it is working. So we move on towards next program. Build a solution. So our next program is write an AVRC program to toggle only bit 4 of port B continuously without disturbing the rest of the pins of port B. So we have to only use port bit 4th of port B. So we have include standard AVR header file. We have used port B as an output, and you can see these new commands that port B is equal to port B or 0B 0001 0000. So this what it's doing is it is using fifth bit. This is bit 4 of port B, or fifth bit of port B, and the next command is port B is equal to port B and 0B, 111 0 111. So it is doing a toggling manually. So it is clearing bit 4, that is fifth bit of port B. If I show you this, that is an output, and this is the fourth bit or the fifth bit, you can say it either ways. And this is just working like that. Once it is 0, once it's 1, once it's 0. So it is showing only my port fifth or fourth. Why it is remaining in this port? Only because we're using this and commands. That is of R, actually of. So this is only outputting me 1, and the next one is outputting only 0. So, and it's only outputting 0. So let us move on to our next program. Next program is, so this one, 714. So we are using 714 in this program. So what is 714 doing is write an AVRC program to monitor bit 5 of port C. If it is high, send 55H to port B, otherwise send AAH to port B. So what it will be sending, it is how we have port B, port DDRB, DDRC, and DDRD. So B and C is output port and C is an input port. And what we are doing is using a while loop, and in while loop we have if else statement. If is adding of pin C, and it is outputting all the zeros, and it is 0, and we are using port B as an output for this, and we are getting the on of 55, and else we have to display A. So if I build this successful, my start debugging, we're using port B as output, so I will just remain on port B. So port B we have, you can see previous step. Previous step we have AA over here. You can see it's showing AA over here. Once moving in else, if, and then moving out of else. So it moves like that. So in next program we have 715. So 715 will say so build project. So we are using 715 over here. So the statement of 715 says a door sensor is connected to bit 1 of port B, and an LED is connected to bit 7 of port C. Run an AVRC program to monitor the door sensor, and when it opens, turn on the LED. It is a similar case, that is, they are taking input from one port and outputting from other port, but we are also using a single bit this time, not all a port. So start debugging. So we are using this DDRB, and we'll use the ports, that is 0 in this case, I think 1 in this case. So port pin 1 of port B is input, and pin 7 of port C is an output port. So we're using 1 in this port, 0 in this port. Okay. So in if condition, we have check pin 1, that is second pin of pin B, set pin 7, that is eighth pin of port C, and else we have clear pin 7, eighth pin of port C. So you can see clearly. I think we have to bring the new one. Higher ports. So so and this way it was working. If I move on towards this next program, let's move on to something different and new. Let's move on towards 19. So here in 19 we have write an AVRC program to get the status of bit 5 of port B and send it to bit 7 of port C continuously. Include AVR, we are including AVR, and then the standard header file. Then we have DDRB, and we are using the fifth bit of port B as input, 7 bit of port C as output, and then we have this while loop, and this while loop never ends, and we have pin if pin B is equal to this, that is we are using it as a input. If one fifth is 1, and for port C is equal to port C, that is, or C is bit 7 of port C to 1, and else we have clear bit 7 of port C to 0. So yeah, uh, stop debugging. Start debugging. So so that was it. Don't know why it is not working. I see it stopped. I think it stopped. Start debugging. And I will codes. Okay, so we have over here we had the 19 program. Now we are moving towards our next program. It will be 721B. Okay, so we are moving on 721B. That is, use bitwise compound assignment operator, rewrite example 19. So we have done example 19. We are just rewriting it, and we have what we have changed is we are using uh, use bitwise command. We are using bitwise command, that is ddr b and is equal to 0b 10, ddr b 0b 110 11111. So bit 5 of port B is input, and bit 7 of port C is output. So in while loop we have if port B pin B is the input, that is matches, pin B should get input of set with 7 of port C to 1, else port C and 0B, that is a code, clear bit 7 of port C to 0. So what we'll do now is we'll see our next programs. So let's see this 30th one. So this 31 statement, it got the statement that is um, write a C program to perform step B of example 28. If the data is good, send ASCII character G to port D, otherwise send B to port D. So we are using include AVR IO Studio library and listener library. Then we have unsigned chart my data from 0 cross 25 to 0 cross 2, 0 cross 35, 0 cross 2, and 0 cross E8. After this data we have unsigned char x char ddrd is equal to 0 cos ff, make port d as an output, and then we have this equation, and that is for add them together. This equation is for adding them together, and meaning is a part of program. So in this way it is working. So now we have 34th program. So in this program, we have to write an AVRC program to bring in a byte of data serially, one bit at a time, via port C pin 3. The LSB should come in first. So bringing the in data via PCB shifting right, standard AVR header file we are using, and then we are using DRC and is equal to this command. You can see and is equal to negation 1. Negation 1 less than set pin. So in this we are using set pin as input. Then we have a repeat for each bit of register, shift register to left one bit, set pin, copy bit, series of pin of port C to LSB add of register. So in this way it was working. So if I move on towards our next program of this chapter, that is 37th or 36th. We were seeing 37th. Okay. So here we have 37th, which is saying that is write an AVRC program to read the content of location 0 cross 005F of EPROM into port B. So we have included the standard AVR header file, then we are DRB that is 0 cross FF, make port B an output, then we have while EER, ECR, and in bracket we have a1 is less than eewe, that is wait for last right to finish, and eear is equal to 0 cross 5f, that is write 0 cross 5f to address register, and eecr is equal to 1 less than eere start EPROM read by writing eere, port b is equal to eedr, that is move data from data register to port B. So in this way these codes are working.